Okay, so we're going to talk about something called partial pressure of gases. This is actually called Dalton's law of partial pressure. And what this is most of the time when you have a gas somewhere, it's not a pure gas, it's a mixture of gases. And what Dalton's law of partial pressure says is that the sum of all the partial pressures in a different gas mixture is equal to the total pressure of the mixture. So the formula that we use for Dalton's law of partial pressure says P total, which would be the total pressure of all of the gases in a mixture, equals PA plus PB plus PC, on and on and on, however many types of gases there are in the mixture. So you literally just take the partial pressure of all gases in the mixture and add them together, and that's going to give you the total pressure of that mixture of gases. So this is going to be important because in a few weeks you're going to do a lab, or at some point this quarter you're going to do a lab called the unknown metal. The unknown metal lab, and you are going to be reacting two things together, and you're going to be producing hydrogen gas. But what's going to be important is you're going to have the total pressure based on the atmospheric pressure of that day, but you're going to be collecting this gas over water. So the total pressure is actually going to be the sum, of the partial pressure of water vapor plus the partial pressure of hydrogen gas. So you're going to want to solve for just this, so then you would just subtract the partial pressure of water from the total pressure that's given to you in the lab to solve for the partial pressure of just hydrogen gas. So you'll use this in that unknown metal lab later. So let's look at an example of using an example of how we solve partial pressures. So this problem says the partial pressure of air in the alveoli, which are the air sacs in the lungs, is as follows. So we have a partial pressure of 570 millimeters of mercury of nitrogen, 103.0 millimeters of mercury of oxygen, 40.0 millimeters of mercury of carbon dioxide, and 47.0 millimeters of mercury of water vapor. And then the question would say, what is the total pressure of air in the lungs, which is what the alveoli are. So this is literally just adding them all together. So this is separate from that problem up there. Okay, so air is made up of nitrogen, oxygen, carbon dioxide, and water. So when we think of air, we think it's mostly oxygen, but that's just really because oxygen is what our cells use for what's called respiration, but there's actually a lot more nitrogen in the air that we breathe than oxygen. So this question is just asking, what's the partial pressure here? So whenever we're using Dalton's law of partial pressure and you're just adding up individual partial pressures to get the total pressure, it doesn't matter what the unit is as long as they are all the same, because you can only add similar units together. So if you were given some of these in atmospheres, some of them in torr, some of them in kilopascals, you would have to convert them all to the same unit before you could add them. These are all in the same unit. So I'm going to say P total equals, and the way that you write this is P, and then down here you write what it is. So this is the partial pressure of nitrogen. That's how you would read this, P with the little N2. This is the partial pressure of oxygen, plus the partial pressure of carbon dioxide, plus the partial pressure of water vapor. So these are the four gases that are in the mixture of air, and the total pressure of air is the sum of all the partial pressures of the gases that are in this air mixture. So we're just going to take them and add them together. So we're going to say 570 millimeters of mercury plus 103.0 millimeters of mercury. Whoops, plus. These are pluses here between these parentheses. Plus 40.0 millimeters of mercury plus 47.0 millimeters of mercury. When you add all these together, you get 760 millimeters of mercury. And when you look at your conversion chart, you'll see that this is 1 atmosphere of pressure. That means this is atmospheric pressure at sea level, which is what you would expect the pressure of air to be in your lungs based on what location you're in. But that is all you need to know about partial pressure. There are some other examples where you're calculating mole fraction, where you would, let's just do one of those up here. Using this same problem, let's say, what is the mole fraction of each component in alveolar air? So what that means is you're just going to take the partial pressure of that gas divided by the total partial pressure. So I'm going to say for nitrogen, it's going to be the partial pressure of nitrogen over the total partial pressure. So for nitrogen, it would be 570 millimeters of mercury divided by 760 millimeters of mercury. The mole fraction for nitrogen is going to be 0.7500. That's the mole fraction. That is like the percentage. If you were to multiply it by 100, you could convert this into a percentage. This would mean 75% of the air that we breathe is nitrogen. So let's look at the next one. Let's look at oxygen. We'll say the partial pressure of oxygen over the total pressure. 103 millimeters of mercury divided by 760 millimeters of mercury, and that's going to be about 0.1355, so about 13.5% if you were to convert it to percent. Let's look at carbon dioxide. That would be about 0.0526, so about 5% if you were to convert it. And then up here, let's look at water vapor. about 6% water vapor. So when you know the total pressure, you can determine the mole fraction of each part in the total gas mixture if this is something that you are being asked to do on your homework.